overloading, everything has to be different apart from the function name. Here, the entire method will be the same. The entire function declaration will be the same. Okay, except for the implementation, because here the child class would like to go for certain kind of modifications in the body. Okay, in the implementation part. So that is what overriding is, and overriding is always achieved via inheritance. Okay. You can only override a method of your superclass. Okay, same class method you cannot override. The method that has been inherited, only that method can be overridden. Okay, so here I have given some examples. Oh. Okay, so it is the same example. Let me just explain here. See, this is a parent class. Okay, this parent class has, and I've given the same name. Okay, I've given the name as per the class. So this is class parent. This has one method display. Okay, and inside display, what do we have? We simply have a message which will display inside parent class. Then we have a child class with the same name child, which extends the parent class. So it clearly means this is the subclass of parent. Inside which, okay, so this is the inherited method display. Okay, and if you see, the data return types are same, the function names are same, and in fact the signature, the argument list is same. Here we, since it is void type and we are not using any, we are not returning anything, so it is empty here. Okay, so here the argument list is also same, that is null. Okay, and then inside we are displaying a message which will simply display inside child class. Okay, the implementation is different, other than that everything else is same. Okay, now you see we have a third class. Okay, we have a third class which is override 1, and inside that class we have a main function. Then what are we doing is we are simply creating a object of the child class. Okay, we have created an object of the child class C, and then we have simply tried to call the display method. Now let me ask you one thing. When this C dot display will be called, okay, when this method will be called, you see, C is an object of the child class, and you know that in inheritance, the child inherits the properties of the parent class. So what do you understand? That this child class, okay, it has the display function of its own. Also, it has inherited the display method of its parent class also. Okay, so now it has both the display methods. One is this and one is this. So now when you call the display method from its object, okay, from the child class object, now will the compiler understand which display method has been called? Because if you see, there are clearly two display methods. Now will the compiler understand? Because if you look at the argument list also, it is the same. The function name is also the same. So had it been method overloading, then the compiler would have understand by simply looking at the argument list. Because in case of overloading, though the function name is different, it can make out using the, by looking at the argument list. But here the argument list is also, it cannot be considered because everything has to be the same. So when everything is same, how will the compiler understand that which display method has been called? So this issue cannot be resolved at compile time. Only when you will be executing your program, when your program will be running, this issue will be resolved at the runtime. Okay, so when this particular message will be displayed, okay, because you see this method has been overridden here in the child class. Okay, and the call has been done from the child class, so the first preference will always be given to the child class message because it is overridden. Okay, because the implementation has been changed here, it has been updated here, so the latest implementation is always called. So this the compiler cannot understand. This can be done only at runtime. That is why this is known as, you know, this problem is resolved at runtime. Okay, So here, if I have this same program even here also. Okay, this is the parent class, this is a child class. Okay, with the same with these messages. And then we have created an object. So see, uh, first we will try to check the output for this program. Okay, so what do you see? You see the child class message. Yes, you see that the child class display method has been invoked and not the parent class display method. Okay, because the method that has already been overridden, that has already been updated, that method will be called. Now, question is, what if you want to display the parent class object? Okay, it's the parent class display method. See, you have multiple ways. One is you can first, the simplest way is what? What can be the simplest way of displaying, invoking this display method? Anyone?
Ma'am, make a object of a parent, not child, ma'am.
Yes, yes, true. So one of the simplest ways to, you can simply create a parent class object. Okay, that is the simplest way that you can do. Uh, Here, okay, simply call it p dot display. So this is the what, this is one way you can use, okay, to invoke the parent class display method. Now again, if you check, see, I have the parent class method also, because parent class display method has been called at the last, so we have the message at the last. Another thing is, if you don't do this, one thing also can be done is, what can you do? You have learned many things. There is another way. We learned one keyword to invoke the parent class constructors, methods, variables from the child class. If you remember, what was that keyword? Anyone? We learned a keyword. We learned something just in one of the previous classes.
Super keyword.
Yes, the super keyword. Good. So using that super, because super is always for the super class. So be it variables, be it methods, be it constructors. Okay. So one thing you can do is this will remain the same. Okay. Here, using the child class object, we will call the display method itself. And when the display method will be called, it is this display method which will be invoked. But now we also want to access the parent class display method. Okay, so one way we have seen is by creating the parent class object, you can directly do it. That is okay, fine. But, but however, one more thing that you can do is you simply write, okay, because we want to invoke the display method of the parent class. So first, okay, just before this statement, write super, then mention the method name, this. Okay, now you save it. Yes, can you see? This is another way. Okay, and suppose you want, you don't want to display this method all at all. Okay, you don't at all want to display this method. Suppose I have commented this part. Now what will happen? Let us check. What do you see? Which message has been displayed? The parent class method has been displayed. So what do you understand? In overriding, the implementation part gets overwritten. Okay, it gets overwritten or overridden, however you say it. Okay, so when you have the updated version, it is always the updated method which will be called and not the old one. But if you put this in comment part, okay, suppose you don't have this. Now, what have I done? I have not made any changes here. It is the child class object itself which has invoked the display method. Now, in absence of this overridden method, okay, in absence of this modified method, what we do is, what will happen is, the original display method will be called, and therefore we will have the parent class message displayed here. Have you understood this example? All of idea, Paisa?
Yes, ma'am.
Okay, okay, fine. Next, uh, next, let us come to another example. I've added all these examples here. Okay. See, here also we have another similar example. We have a parent class, then we have a child class, and we have a third class. Okay, the main method can also be used inside the child class. Okay, though I have used separate classes. Huh? Though I have used separate classes here, but this part, okay, this part can be also written inside this child class itself. It is the same thing. Okay, now you see you have a parent class here. So in the parent class, what do you have? You have a variable x whose value is 10. Okay, and then we have a data member, and then we have a member function. Okay, we have a method display which will simply display the value of x for the super class. Fine. Then in the child class we have another data member y whose value is 20, and again we have a display method. Okay, and inside that display methods, if you see, it is the same method which has been overridden. Okay, the implementation is a bit different. So first what we have done is we have again rewritten the same message of the parent class. Okay, it is the same message, and then we have written the child class message that is to be displayed. Okay, so we have two statements here inside the display method, and then we have this override to method inside which we have created a method object of child class, and we have invoked the display method. Okay, so you can now well say, you can now you have understood since, so you can say what the output will be, right? So first the display method, so it is this display method which will be invoked, and whatever is there inside will be displayed, right? So if you see accordingly, however the messages has been written. Okay, so first the super x will be displayed, and then the sub and value of y will be displayed. Okay, and if you want to make modifications of your own, suppose you don't want to write this statement here and you want to you say, let's just make put it in the comment section, and let's just call the super keyword, use the super keyword to invoke the display method. Okay, and let's see how it works. See, it works the same way. Okay, it works the same way because we're inheriting. So by default everything that belongs here will, yeah, belong here, irrespective of the access modifiers that we have. Since we don't have any access modifiers here, so by default it is default, and you know that default serves the same purpose as public, almost like public, except that public is available in fact across packages. Default is not available across packages, it is available inside the same package. Okay, so however, since everything is default here, so anything that belongs to here will belong to here. Okay, so this is it. Fine. Next, we come to the second part, runtime polymorphism or dynamic method dispatch. So all this while we were doing method overriding, so we simply saw what method overriding is. Okay, so see these things, method overloading versus method overriding, so you need to be very much clear about its implementation, about its meaning, about the purpose they serve or why we need it. Okay, one thing that I have repeatedly said is about the rules. You have to remember the rules in case of overriding and overloading. Secondly, the purpose. Okay, overloading is, it is the same function, but it will serve different purpose, it is used for different tasks. Overriding is not for different task. Overriding will do the same thing but in a modified way. Okay, it will do the same thing but in a modified way. Is that fine? You have say I have my mom's sari. Okay, the way she wears it, I might not like it that way. So what I'll do is I'll take it, I'll do a bit of modifications in that, and then I'll wear it. So it is the same thing but I have modified it and I have used it. So that is overriding. Okay, that all these things you have to remember, because these are the things that you might be asked in Viva, and of course you will be asked about all these in Viva. So you have to be very much clear. I'm going a bit slow with Java so that you don't mix up the things, okay? Because there are too many concepts in Java, so that you don't mix up things. That is why I'm going a bit slow. Anyways, next, let's now start with the main topic, which is the runtime polymorphism, which is also known as the dynamic method dispatch. So this is one new, you can say, topic or name that you haven't heard. Okay, so we have been talking about compile time polymorphism or runtime polymorphism, but runtime polymorphism is also known as dynamic method dispatch. Now, why is it known as dynamic method dispatch? So we have the definition here. You see, what is runtime polymorphism or dynamic method dispatch? It is a process in which a call to an overridden method is resolved at runtime rather than compile time. Okay. In this, an overridden method is called through the reference variable of the superclass. So this we will learn. Okay, this we will learn, understand via the example given. So basically, what is runtime polymorphism? So as I have been saying, that in compile time polymorphism, the call to the overloaded method is resolved in compile time. But in runtime polymorphism, the call to the overridden method cannot be resolved at run compile time. Okay, because entire function looks same. So that is why this can be resolved only at runtime. That is why the name runtime polymorphism or dynamic method dispatch, because it is done at dynamic. It is done dynamically, okay, at runtime. Okay, also known as dynamic binding, whatever you call it, dynamic binding, dynamic method dispatch, or runtime polymorphism. Now this point that we need to understand, okay, so in method overriding, what were we doing? We created an object, because see, we can create objects of both the child class and the superclass. Okay, we have also seen that. So if you create an object of the parent class and you try to invoke the overridden method, it is always the parent class method that will be invoked and not the child class. And you know the reason why? Because if you are creating an object of the parent class, okay, then it will always refer to the parent class properties only. Okay, it will not, because parent class, because child class properties do not belong to parent class, so parent class object cannot invoke child class properties, right? So if you create an object of the parent class, then that parent class object will always refer to its own properties. It cannot come to the child class, it cannot come one level lower. But if you create an object of the child class and you try to invoke any method or any property of its own or of its parent class, it is possible, because you are doing inheritance and it is the child class which is reusing properties of the parent class. Okay, so we have seen this multiple times in the previous classes also. Yes, we have gone through a lot of concepts, and here, though we are invoking the same method, okay, it is always the latest method or the overridden method which will be uh, invoked, okay, which will be invoked first, and in absence of this method, the original method will be invoked. So that also we have seen. So here we were only talking about the child class object, the child class object invoking either its own method or the parent class method. Now you see, runtime polymorphism is always achieved using method overriding. That you have to remember. Okay, runtime polymorphism is always achieved using method overriding. Okay, that is why the name runtime polymorphism. So here what are we doing is, we are trying to resolve a call to the overridden method at runtime. Okay, see here, next, the second statement that we will understand through a program. Okay, what is this? Okay, let's not come here directly. Okay, see, we have a program here. See, we have two classes. Okay, this is class B and this is class A. So class A is the child class of class B. Okay, don't get confused because I'm reversing the names here. Class B is just a child of class, sorry, child B is the parent class and A is the child class. Okay, now inside B we have a method which will simply display this message, and inside A, okay, we have the same method, overridden method, where we will be displaying this particular message. It is simple enough. Okay. Next, you see, since we are talking about dynamic method dispatch, we have a slight difference here. What we will do is, in overriding, we have seen that creating the child class object, you can refer to its own class properties or the parent class properties, right? Here, what we will do is, we will reverse the way. We will create objects of parent class, and using that parent class object, we will try to refer to the child class methods or properties, whatever you call it. Okay, so let's see how it can be done. So basically, we will not just এইটো part অলপমান বাদ দিয়া for the time being, এইখিনি বাদ দিয়া অলপমানৰ কাৰণে হা, just ignore this part, highlighted part. Let's come to this. It is the same class. Okay, it is the same test class. Okay, first we will look at this. You see, what are we doing? As I said, we will create object of the parent class. Okay, so here I have parent class is B. I have created an object of the parent class which is obj1. Okay, so it is this parent class object obj1. Then I have created an object of the child class also. Okay, I have created an object of the child class also, a obj2 equal to new a. This is the constructor of the child class. So this is the uh, object of the parent class, and this is the object of the child class. So these are not actually objects, these are what? These are reference variables, if you remember, right? If you remember, so these are used to refer to the objects created for the classes, right? So they will point to the objects which are created for class B and class A. So obj1 is pointing to class B object that is created, and obj2 is referring to the object which is created, okay, for class A. But however, here in this case, you see obj1 is empty. Why is it empty? Because this is not actually an object, if you see, because when do we create an object? How do we create objects? We create objects using the new operator followed by the constructor. Yes, the new operator will create the object and constructor will initialize the properties of that object, right? Here the object creation is actually done for class A. Okay, object creation is not done for class B. We are simply declaring a reference variable obj1 which is empty. It is not pointing towards any object because we have not created any object for class B. Okay, we have not actually created any object for class B. We have simply created a reference variable and we have left it like that, empty. Okay, we have then created an object of class A which is obj2. Okay, with this particular statement. Now what are we doing is, see, this is the important line. We are simply assigning the value. Okay, we are simply assigning the value of obj2. So obj2 contains an address, okay, of the object that is created, right? It creates the base address, you can say. So obj2 is pointing towards an object, so it contains the base address of that particular object. So now whatever value this obj2 contains, that value has been assigned to obj1 now. So what does this mean? Both obj1 and obj2 are pointing to the same object. And what is that object? It is the child class object only. But however, the parent class reference variable is also now pointing to the child class object. This is known as upcasting. This method is known as upcasting. Okay, because what am I doing is I am making the parent class reference variable store the object of the child class. বুঝি পাছ না নাই কি কৈছো? This is obj.
Ma'am,
This is
ma'am,
obj.
ma'am, after that, ma'am, often ako ba pwede mo, ma'am?
কি কৈছা বুজি নাই
B object and B, ma'am, B object and A object to ma'am part of common pwede mo, ma'am?
মই কৈ আছো ৰবা, just let me write it here. মই just বস্তুটো মই diagrammatically দেখাই আছো হা. Okay, so this is the child class of it. Let me just write it here, child class. So, look at this. So as I said, what are we doing? First, you understand here, okay, the difference. In method overriding is simply a technique, okay? Method overriding was simply a technique where we would override an already existing method in the parent class, okay, and use it in the child class with some minor modifications in the implementation part only. Okay, so implementations are modified, that is overriding. And we have seen that how creating child class objects. So in inheritance you have seen, because overriding is achieved, in inheritance only, by inheritance. So you have seen in inheritance that whenever you create child class objects, you can directly access the parent class properties also via those objects. So it is a simple concept that we have used here, right? We have not used anything new in overriding. Now we are talking about runtime polymorphism. Okay, so it's a concept. Overriding is a technique, okay, and runtime polymorphism is a concept, and this concept can be achieved by the technique method overriding. Okay, so this is what we will do here. We will override the methods. Okay, and one more thing that we will do here is we will create objects of the child class, but however we will use some reference variables of the, we will create at the same time, we will create reference variables of the parent class, and using that reference variable of the parent class we will store the child class object, and that is how we will be invoking the properties of the child class and its own class also. So that we are looking at right now. Okay, so I have ignored this part. Okay, for a time being, just look at this first. What I have said is, first, as I said, we will be creating reference variables of the parent class. So B is the parent class, okay, and then we have created an object. So this is not actually an object now. Okay, this is not actually an object now, because when do we create, when do we say that we have created an object? When we write this entire statement equal to new plus the constructor, right? Because when you simply declare a variable, when you write a variable with the class name, it is simply a reference variable, it is not an object. When does it become an object? Only when you create object using the new operator. The new operator is meant for creating objects, and you assign, okay, you initialize that object using the constructors, okay, whatever constructor you use. Now as you can see here, we are not creating any object here, we are simply creating or declaring a reference variable. It is a simple variable obj1, okay, with of what type? Class type. Yes, so this is a class type object reference variable, so it will refer to a particular object, but here we have not